All right, guys, today we got to talk about rhombuses or rhombi, if you want to get really fancy about it. What I want to focus on today is this, that a rhombus is a type of parallelogram, right? So all the things that we said about parallelograms are also going to be true about rhombuses. There's just a couple additional things. Some of them I'm going to be able to show you today, and some of them that you're actually going to have to wait on until we put this on the coordinate plane next week. So the one big thing that sets it apart is this, is that in a parallelogram we had opposite sides parallel, and that was the only part of the definition. There are rules that we can tell from that, but the additional things you know from a rhombus is that the opposite sides are parallel, but they're all also congruent, okay? So that's your extra piece of information, and what that does is that changes a lot of things. So say, for example, one of the things we talked about was diagonals, right? And one of the things we showed last week was that in a parallelogram, you had two congruent triangles that this created. Well, that's still true here. More specifically, though, there are two isosceles triangles, right? And again, if I kind of draw another one, you're going to find something out, okay? So these diagonals still bisect one another, right? So one of the things we talked about last week was this. I'm going to do it in a different color, just so, okay, is that these bisected each other, right? That these were the same length and that these were the same length. But you guys know from talking about isosceles triangles that if I split the base, right, if I dropped, you know, this and I split the base to two equal parts, we also know that these are now right angles, and we also know that these angles have not bisected each other. So those are the extra nuggets of information. So I'm going to clear some of the stuff off of here just to kind of show you guys some of the things. Some of the additional things that we know. Okay, so everything we know before is true, so they can still ask you questions about those. But what it really comes down to essentially is that you have four congruent triangles. I'll label them for you in a second. So these four angles are the same. I'm sorry, I don't know why it insists on making me write like a crayon every time. And these guys over here are the same as these guys over here. So what you get are four congruent triangles, and we didn't have that with a rhombus. And that's really the big thing you're going to have to look out for, okay? Is that essentially you have these four congruent triangles, and they're all kind of reflected about, you know, over these diagonals onto each other, okay? So you got right angles in the middle, you have your diagonals bisect each other, you have all your sides congruent, and you have four congruent triangles in the middle. That's all the extra information you really need to know about a rhombus. But again, keep in mind, if they say, hey, it's a rhombus, all those things we said about parallelograms also apply. Also, things to keep in mind, just like we said a rectangle was a type of parallelogram, a square is a type of rhombus. So if we talk about these things, and there will be additional things for squares, yes, we'll talk specifically about squares, but if they give you a square, all these things are true, okay? You're going to do this, right, and all those things are true. You're just going to have some extra information that you know, right? So let's take a look at some questions that you guys can see today, and then I'll set you guys loose for it, okay? Okay, so quadrilateral EFGH is a rhombus. So they told you it's a rhombus, okay? They're not always going to mark it up. Sometimes they're going to tell you in the problem. What is the measure of angle FHG? They want to know what is this angle over here, okay? Well, some things we know. We know that that angle is the same as this angle, right? That the diagonals bisect one another. That you had first from a parallelogram that your opposite angles were congruent, and then a rhombus takes this step further, right? So in fact, we can find any of these, okay? But you guys also know that this is an isosceles triangle over here, and this is an isosceles triangle over here. And we know that because all the sides are congruent, right? Therefore, your base angles are congruent as well. So it all kind of falls into place, okay? So what can we say? We can say that how can we find these angles? Well, I know that in a triangle, it's 90 degrees, right? right? And I'm going to go ahead and I'm going to say that this one's 58 over here, right? Because we know that opposite angles are equal. And I'm going to call this one for a second x, and I'm going to call this one for a second also x, right? Because we know that they're both the same length. They're both the same number of degrees, right? So let's go ahead and let's set up an equation. We'll say x plus 58 equals, and you guys were about to tell me I was about to set it equal to 90. I'm sorry, 180 degrees. 100. I'm sure you guys are all yelling at the screen out there. Okay, 180 degrees, right? Good. So again, let's subtract 58 from both sides. What are we going to find out? 2x is equal to, what is that, 122? 122 degrees. Let's divide by 2. We'll find out that x is equal to 61. Again, just let's double check. 61, 61, and 58. Does it make 180? Yes, it does. Okay. So how big is this angle, FHG, that they asked us about? That is going to be 61 degrees. Okay. Just make sure you watch out what they're asking for. Okay. All right. Quadrilateral WXYZ is a rhombus. What is the measure of angle VXY? VXY. So they want this angle right here. All right. Let's go with what we know. First of all, we know that in a parallelogram, you have perpendicular bisectors in the middle, right? So we know that that's 90. We know if this is 64, again, if you wanted to, alternate interior, 64. But in fact, things we know now, these are all 64, right? It's unique to rhombuses, right? So again, let's call this angle for here a second x. And I know that x plus 64 plus 90 degrees in the middle has to equal 180, okay? We're going to see a shortcut for this in a second. Well, when I subtract 90 from both sides, right, we can just say that x plus 64 is equal to 90, okay? And again, I know you would have combined these, but I do want to show you, though, if they give you two of these angles right here, you can just go ahead and say that they're complementary, that they add up to 90 degrees, because you know that there's 90 degrees taken right here, okay? So any two consecutive, I don't know what you want to call them, any two of these consecutive bisected angles are going to equal 90. So just a good thing to keep in mind. It can give you a little shortcut. So again, we're going to subtract 64. I'm going to say that x is equal to 26 degrees. All right. Again, pretty straightforward. What do you know, though? If they tell you it's a rhombus, I'm going to tell you it's a rhombus because I cut off that part of the question. Okay. So this is a rhombus. What do you need to know? That these two things are equal. C plus 35 is equal to 6C. Set them equal. 35 is equal to 5C. Let's divide by 5. I'll find out that C is equal to 7. Okay. All right. It says quadrilateral VWXY. VWXY is a rhombus. And the measurable angle UWX, this right in here, is in 6W plus 49. Okay, now again, let's think of things we know. We know that this is 90, right? So if this triangle right here is the one we're going to be working with, well, we know that these angles are also the same because that's one of the things we know about rhombuses. So we can actually say that for both of these angles. So what do I know? Well, if there's 90 there and this is a triangle, well, I know that these two have to be complementary, right? So what are we going to say? We're going to say 6W plus 49 plus 35 is equal to 90, okay? Again, I know the urge to set them equal to each other and they're not equal. You can't just do that because you feel like it. 6W, is it 49 and 35 is going to be 84. Okay, and that means that W is going to be 1, right? 6 plus 84, but let's see it through. 6W is equal to 6, which means that W is equal to 1. Okay. Again, don't always set things equal to each other. Sometimes they're going to be complementary, sometimes they're going to be supplementary. Okay. They want to know, I don't like this question because they use Y and also Y, but that's okay. Angle WVX. Well, WVX is going to equal 4Y minus 82. Right? And a little bit trickier this time, but one of the things you do have to remember is that this is an isosceles triangle, right? So if we think about it, that angle, which is also over here, if I add up this angle, and this angle, I should get 180 degrees. So what are we going to say? We're going to say 4y minus 82 plus another 4y minus 82 plus 128 is going to equal 180. Well, 4y and 4y is 8y, negative 82, and negative 82 is going to be minus 164. Okay. 164 and 128 is going to be, what is that, 64, 28, early in the morning, 36, maybe 36. Oh, that's right, is that right? All right, we're going to add 36 to both sides. We'll find out that 8y equal to 180 plus 36, which is going to be 216. And divide by 8 on both sides. We're going to find out that 8 goes into 21 twice, and the remainder 5, so 27. Okay, so y is an equal 27. Okay, I believe that's it. Have fun. I'm also going to put another suggested skill in there for you guys to do today. This work is not actually due until Thursday, so there'll be no class tomorrow. We'll know new stuff tomorrow, so tomorrow's going to be a day to catch up. But I'm going to also add an additional skill in there for you guys to practice. Okay, have a good one. Take it easy.